everyone, welcome to learn about the factors affecting precipitate purity. In precipitation gravimetry, the solubility of precipitate needs to be small, and the precipitate should be as pure as possible. However, because the precipitate is produced from the solution, other components in the solution are more or less mixed, which may cause a pollution of precipitate. The main factors affecting precipitate purity are cold precipitation and post-precipitation. During the precipitation reaction, some soluble impurities are precipitated at the same time, namely cold precipitation. Cold precipitation is mainly caused by surface adsorption, mixed crystal formation, and occlusion, which is one of the main sources of error in gravimetric analysis. Now, let's study surface adsorption cold precipitation. Precipitate is usually a crystal composed of anions and cations arranged in a fixed pattern in space. However, the crystal ions located on the surface, sides, and corners of crystal particles carry certain positive or negative charge due to the unbalanced charge distribution. The impurities will be adsorbed on the surface of the precipitate, producing cold precipitation. This phenomenon is called surface adsorption cold precipitation. For example, inside the barium sulfate precipitate, each crystal ion is surrounded by ions with opposite charge and is in a statistic balanced state. But on the surface of precipitate, barium of sulfate has at least one side that is not surrounded by ions with opposite charge, and thus has the ability to attract ions with opposite charge. The precipitate surface firstly adsorbs the excessive crystalline ions in the solution, forming the primary adsorption layer. For example, when barium chloride solution is gradually added into the barium salt solution, precipitate first adsorbs excessive barium to form adsorption layer. The precipitate is positively charged at this time. To remain neutral, this adsorption layer will sequentially absorb ions with negative charge, such as chloride, forming the second adsorption layer, namely diffusion layer. The adsorption layer and the diffusion layer constitute the electric double layer at the surface of precipitate. The ions in the electric double layer can be sedimented together with the precipitate, causing contamination. Surface adsorption is selective, and the rule of selective adsorption is: firstly, the primary adsorption layer prone to adsorb the crystalline ions. For example, the barium sulfate precipitate is more likely to adsorb barium. Secondly, the ions with a similar size and the same charge as the crystalline ions are easy to be adsorbed. For example, barium sulfate precipitate is easy to adsorb lead. Thirdly, ions with higher valence are easier to be absorbed. For example, ferric is easier to be adsorbed than ferrous. In addition, the ions which can react with the crystalline ions to produce compounds with lower solubility or less dissociation are easy to be adsorbed. Generally, the greater the total surface area of the precipitate, the greater amount the absorbed impurity is. Amorphous precipitate absorbs more impurities than crystalline precipitate, while fine crystal precipitate carries more impurities than large crystal precipitate. The higher concentration of impurities is in the solution, the greater the adsorption will be. Adsorption is exothermic, so the impurity adsorption decreases when the temperature increases. In the precipitation gravimetry, the adsorbed impurities can be reduced by washing. Next, the mixed crystal. In the precipitation process, if the impurity ions have similar radius, electron structure to crystal ions, as well as a formed crystalline structure, it is quite easy to produce mixed crystals. Common mixed crystals are barium sulfate and lead sulfate, silver chloride and silver bromide, etc. The shape of this kind of mixed crystal is often incomplete. The impurity ions will be gradually driven out when placing together with a metal liquor, and the shape of mixed crystal will slowly become complete. Thus, more pure precipitate can be obtained. The last co-precipitation phenomenon is occlusion. In the precipitation reaction, due to the fast speed of precipitation generation, the impurities or metal liquor absorbed on the surface of precipitate is not able to leave. They may be embedded within the inner of the precipitate, which is called occlusion. The amount of occlusion is also associated with the general mechanism of surface adsorption. For example, when barium sulfate is precipitated, the occluded amount of barium nitrate is larger than barium chloride, because the former has a smaller solubility and is easier to be trapped into the precipitate. Such impurities cannot be removed by washing. Aging or reprecipitation can effectively purify these precipitate. Another important factor affecting purity is post-precipitation. Post-precipitation refers to the subsequent precipitation of a chemically different species upon the surface of an initial precipitate. Such species are commonly difficult to be precipitated or can't be precipitated alone because of stable supersaturation solution. The longer time the post-precipitating compound is placed, the more post-precipitation is obtained. For example, when hydrosulfuric acid is bubbled into an acid solution containing copper and zinc, the initial copper sulfide precipitate does not contain zinc sulfide. However, as a long-time incubation of copper sulfide in metal liquor, extensive adsorption of sulfide happens on the surface of the copper sulfide precipitate, leading to the precipitation of zinc sulfide. The amount of impurities induced by post-precipitation is more serious than that of co-precipitation, especially after long-term incubation. Therefore, shortening the exposure time of precipitate to metal liquor is a main approach to reduce the interference from post-precipitation. Although co-precipitation and post-precipitation are negative factors, sometimes they can be also transformed into positive factors. For example, co-precipitation separation is a useful method for enrichment of trace components in solution. At the end of this course, please recall what are the factors that affect precipitate purity. What is the adsorption mechanism on the surface of the precipitate, and how to reduce impurities adsorbed on the surface. That's all for today's lecture. Thank you for your participation.